From the College of Business and Economics at Boise State University, this is BUSMBA550. My name is Regis Turpin, and the topic of this video is EOQ model with quantity discount. In my previous video, I was talking about the basic EOQ model. As a reminder, the basic EOQ model is a pretty powerful model that was adopted a while ago and is still being used today. And the basic EOQ model is very useful at determining what lot sizes you should purchase if you want to minimize inventory cost. Now, if you remember, the basic EOQ model had a lot of assumption attached to it. And because of that, it's not very realistic. So the goal of this video is to introduce a model where we remove one of the assumption, which is the assumption about the quantity discount. One of the assumptions of the basic EOQ model is that you would not consider any quantity discount, and as we know, it's not very realistic because it is a very common practice among salespeople to entice buyers to buy more than necessary by giving them quantity discount. So the idea is that if you purchase more or larger lot sizes, then you're going to get discount. So that's what we want to factor in this model here. So what you're going to see is that the total cost function looks very similar to that of the basic EOQ model, but with one key difference, which is that this time we're going to factor in the purchasing cost of the item. So not only we would have the setup cost, the holding cost like in the basic EOQ model, but this time we're going to add the purchasing price, which is the price per unit multiplied by the annual demand. Why do we do that? Well, the reason we do that is that what we're trying to find out is what happens when we get a discount here in the price of purchasing item, because that's what this model is about, is you're going to get some kind of quantity discount if you purchase a certain volume. So we want to know if the discount that you're going to get in this area is going to make up for the possible price increase in other area of the equation. In fact, if we look at this equation and wonder what is going to change if we are getting a quantity discount, well, what you should expect is that the price multiplied by demand is going to decrease because you're going to receive some kind of discount here. Now, what you're going to see is that because you're purchasing a higher volume of item, your holding costs are going to increase here. And finally, your setup costs are going to decrease because if you order in larger amounts, then you don't need to order as often, and therefore the cost of generating those purchases is going to go down. So overall, what we're trying to determine is whether the decrease in setup costs and purchasing costs are going to make up for the increase in holding costs. That's the goal here. But in any case, we need to consider all three costs here, not only the two that we had before. So what I want to show you now is the method that we adopt to solve the quantity discount EOQ problem. So the first step is going to be to compute EOQ for all the possible scenarios. So it's very similar to the basic EOQ model. The only difference here is that we're going to calculate the EOQ quantity for each possible price option. Number two, we're going to determine which option is feasible. And here by feasible, I mean if I order the EOQ quantity that I calculated in step 1, would I qualify for this price? If the answer to that question is no, then it means that the option was not feasible, and the answer was yes, then the option is feasible. Now, if the option is feasible, we jump to step 3, which is we're going to calculate the total cost, which is setup cost plus holding cost plus purchasing cost, at the EOQ quantity, and that's only for the feasible option. Now for the non-feasible option, I'm jumping to step number 4. I'm also going to calculate the total cost, which is setup cost, ordering cost, and holding cost. But this time, I'm not going to use the EOQ quantity in my computation. Instead, I'm going to use the minimum quantity that would qualify me for that price option. In step number 5, I'm going to compute the total cost for all options, regardless of whether they are feasible or not. And we're going to choose the lowest cost alternative of all of them. Finally, step number 6, we're going to look at other issues that may be more qualitative in nature, but are also important and relevant to our decisions. So the best at this point is to use an example to illustrate what I just said. So imagine you are this company and you are selling hats and you're purchasing those hats from a supplier. Now, the present supplier charges $10 for each hat and requires minimum quantities of 300 hats. So if you want to get the $10 price, it means that you have to order 300 hats minimum. The annual demand for the hat is 12,000 hats. The ordering cost $20 per order, and the inventory carrying cost is 20% of the hat cost. By the way, this is a common way of expressing the carrying cost or setup cost is to express it as a percentage of the item cost. And now there's a new supplier that is coming to you and is offering you the same hat for $9 instead of $10, but the condition is that you have to purchase them in lots of 4,000 or more. So the question is, who should you buy from? So I'm going to apply step 1 and 2 for option 1, which is the $9 hat, which is the cheaper of the two options. So you see that if you calculate EOQ here, you're plugging the number. So it's 2 times the demand, that's 12,000, multiplied by $20, that's the setup cost. And you divide by 20% of $9, that's $1.80. If you do that, your EOQ quantity is 517 hats. Step number 2, you ask yourself, is it a feasible solution? How do I know? Well, you ask yourself, if I wanted to purchase the quantity of 517 hats, would I qualify for the $9 price? And the answer to that question is not, because the condition to be able to purchase the hat at the $9 price tag was that you order quantities of 4,000 or more. So that solution is not feasible. Next, I'm going to do the same thing with option number 2. Option number 2 here is the $10 hat. And here we only have 2 options, so that would be the last of our option. So step 1 here for option 2 is, again, to calculate EOQ, but this time at $10. So the equation would be exactly the same. The only thing that would be different here is the holding cost, which would be 20% of $10, and that would be $2 instead of $1.80 previously. This is our new EOQ quantity here, 490 hats. Again, I'm asking the question, if I wanted to purchase 490 hats, would I qualify for the $10 price tag? And the answer here is yes, I would, because the condition to get the $10 hat was to buy quantities of 300 or more. So at 490, we're fine. So this solution is feasible. Next slide, step 3, and we're going to calculate the total cost option for feasible option. So feasible option, we're looking at total cost at $10 here. So this is here the setup cost. That's the demand divided by the EOQ quantity multiplied by $20 per order, plus the holding cost. So that's the quantity divided by 2 multiplied by $2 at the holding cost. And finally, this is the purchasing cost. So 12,000 hats per year at the $10 price tag. That's a total of $120,980. Step 4, we're going to do exactly the same thing, but for the non-feasible option. So the main difference between calculating the total cost for non-feasible option and the one for feasible option is that instead of entering the EOQ quantity in our equation here, we're going to enter the minimum quantity that would qualify us for the price discount. So if we wanted a $9 deal on the hat, the minimum we should order it would be 4,000. So that's what we're going to enter in the equation instead of EOQ quantity. So that's demand divided by this quantity here, multiplied by $20. Again, everything is similar to before. The only thing that changes is that we don't use the EOQ quantities. Another thing that changes, of course, is that we get a discount here. So we're saving $1 for each hat. So altogether here, if I look at all those costs, I get to the total of $111,660. Step number 5, we're looking at which of the two options is the cheapest, and in this case, this is a clear win for the $9 hat here. 111,660, it's almost $10,000 cheaper than the other option. So in all, it is worth purchasing in quantities of 4,000 because we're going to save a lot of money. And you can tell from the equation here that the reason we're saving so much is because the $1 multiplied by 12,000, that's already $12,000 saved just in that area. So maybe the holding costs are going to go up a little, but it's more than made up by the decrease in the purchasing cost here. Step 6 is other consideration. So you have to ask yourself more qualitative things that it cannot be captured in number here. So for instance, do I have enough room to accommodate orders of 4,000 or more? So maybe a hat doesn't take a lot of space, but if you're purchasing very bulky items, for instance, you would have to ask yourself, can you accommodate the space for all those items? You could also have issues of perishability. So if you're purchasing, let's say, yogurt, and you had to purchase very large volumes, so would they go bad before you can sell them? So that's the kind of question you have to ask at this point in time. I mean, just to make sure it's not only a dollar consideration, but you're taking into account a lot of other things. So this is it for this method, and I hope this was useful. In the next video, I'm going to introduce some other variation of the EOQ model.